Hello, welcome to my presentation. My name is Mitch Blum. I'm with HDR Engineering, and I'm going to talk to you today about the Carson River physical map revision and that process, and kind of how we're pushing boundaries and changing things with flood hazard mapping in the Carson River. So I'll talk a little bit about the regulations, the NFIP, National Flood Insurance Program regulations, how those have changed, the map revision process, how we're coming at mapping our communities a little differently, and then some of the different scales of mapping, and how that affects the Carson River. I'll talk a little bit about kind of the hydrology involved in these studies and how it's a new paradigm compared to old original style studies, and then focus on hydraulic modeling, two-dimensional hydraulic modeling, and how that's expanding our understanding of floodplain dynamics and flood mapping, and then talk a little bit about the new guidance that FEMA is coming out with and how this study in particular fits into that guidance and how we're kind of pushing new boundaries here with this study. Um, so the National Flood Insurance Program was started in 1968, and those regulations have not changed much since that era, and they reflect the technical capabilities at that time. They're based upon a regulatory framework from the 70s, and the tools that we had in the 1970s. The 44 CFR Code of Federal Regulations is what guides mapping and flood insurance regulations, and that was written when really all we had was steady state, one-dimensional models. Those were state of the art, and they were run on, mainframe computers, and it was FEMA set out to map the entire country for flood insurance purposes on a limited budget. So the tools and the regulations and the modeling were all very simple at the time. Moving on to current guidelines, those are still a bit antiquated, so to speak, and there's very, very limited guidance until very recently on two-dimensional modeling. So essentially, the technology has exponentially grown, and our computer capabilities have grown, and the guidance and the regulations have not kept up with our capabilities as far as mapping, physically mapping the floodplains. So the map revision process from FEMA, the original map revision process was initiated by FEMA. When a community, applied for map revisions, FEMA would initiate that study. FEMA would manage the study. FEMA would hire its own contractors, and there was a limited number of studies each year. And these were kind of based on cost benefits. So the communities would apply, and then, maybe they would get their floodplain studied, or maybe they wouldn't. The FEMA study contractors could be from anywhere. So this stuff was kind of done in a bubble, a FEMA bubble, so to speak. So we're changing that paradigm with the Carson River and the cooperating technical partners. They used to just hand down flood maps. So cooperating technical partners. This is the new flood map revision process, as opposed to that old process that FEMA, dictates all the study contractors and hands you down the maps. This is a community-initiated revision. It's through this CTP, cooperating technical partner, and the Carson Water Subconservancy is a cooperating technical partner. And it's an innovative program that was created to basically give the communities a lot more input into the process. They wanted a partnership between FEMA and the communities. And the community actually manages the work. And they're using local resources, local consultants, local agencies to conduct that work. And so FEMA is holding the purse strings. It's a grant-based funding, but it's not based on cost benefit anymore. It's not being done in the FEMA bubble. Communities apply. The communities that are part of the CTP program apply for grant funding, and then they have a lot more say and a lot more input on their flood boundaries. This is also sort of a new paradigm, and we're using this in the Carson watershed. So just some pictures of the flooding in 2006 and 1997. This is really what inspired the Carson Water Subconservancy to begin, diving more heavily into flood management. The 1997 event, so to speak. Just some more images of the floodplain, and as you can see, this is a very dynamic floodplain. Some of the original tools that we used to model and map these floodplains just don't work in this wide, kind of expansive floodplain where the water can bifurcate and move all over the place. And subsequent to the 97 flood, the Carson Water Subconservancy started looking at, a regional floodplain management plan. And that plan was pretty innovative at the time. And the agency itself is pretty innovative at the time. It's a multi-state, multi-county jurisdiction, and they wanted to look at cumulative floodplain management. So, for instance, impacts up in the Carson Valley and Douglas County can affect, amounts of water and timing of the peak flow, down through Carson City and below. So they needed a better tool to assess these cumulative impacts, and to redo these vintage studies. All these studies that were done with very simple models and very simple techniques were done in the 80s. And they really couldn't map the areas in the Carson Valley that were so complicated with the hydrodynamics. So the CWSD set out to, look at these impacts cumulatively with this tool that could now assess peak flow, volume changes, stage changes, and timing. The old steady state one-dimensional models could not assess all these different impacts to the floodplain based on construction or development in the floodplain. So I want to talk a little bit about the FEMA revision scale, how these maps, there's different, scales of mapping. So a flood insurance study, which was kind of the original, FEMA process, was a community. They were mapping communities. Let's say it was a county or a city. Physical map revisions are a little bit different, and it's one or more map panels are being revised, and this is also a physical map revision, which is what we're doing for the Carson River, is also part of the CTP process. So if the study is funded through a grant from FEMA, it's a physical map revision instead of FEMA doing all the work themselves. A letter of map revision is a little bit different. That's a very smaller scale map revision that's initiated by an individual or a city or something like that, and it revises just a small portion of the flood insurance maps. So that's a much smaller scale. So let's talk about our specific study, the CTP, physical map revision for the Carson River. We are mapping 3 counties, 3 municipalities. There's 2 states involved, and we're doing this in essentially 3 phases. And you can see that in the different color coding here. We started in Lyon County, and then we moved to Carson City County, and then to Douglas County. And right now we're in the process of finalizing the Douglas County reach. The Carson City reach and the Lyon County reach, the floodplain is fairly confined in that area. We don't have these hydrodynamics that we do in the valley, the Carson Valley area. So those models were done with a one-dimensional. We still looked at an unsteady state flow, but it was a one-dimensional model. So let's look at this unique kind of methodology that we're using to map and model our floodplains. We wanted to look at cumulative impact. Steady state models cannot look at timing of flow or changes in peak flow due to the movement of water through the floodplain or due to impacts in the floodplain. So we are using what they call an unsteady state flow, which is time and flow, which you can see on the graphic here. It's not a single peak flow, which is probably what most people are used to seeing. It's a flow over time. And we can look at changes in volume and changes in the base flood elevations and changes in the timing of that flow. This is an example here where at the upstream end of the model, you have more flow and it arrives earlier than the downstream end. So you're seeing the impact of flood wave attenuation in this graphic here. That's something you can't see with a steady state flow. So let's look at hydrology. So the FEMA flood insurance studies for this area, were based on estimates made in the 1980s. So we wanted to revise those sort of old estimates because we had some pretty major flooding since the 1980s estimate. And that goes into the statistics which we use to create or estimate our 100-year flood. So we used a revised hydrology, and we needed that hydrograph for that unsteady state. And so we used that balanced hydrograph approach. And so we took that balanced hydrograph approach and created brand new hydrology for the system. You can see the differences at a few of the locations for the Douglas County study. So traditional hydraulic models, as I said, were pretty much steady state, and they're one-dimensional, and that's kind of what you're looking at on the graphics here. You have a very set water surface elevation across the floodplain. It's an instant in time. There's no timing involved. And all your cross sections essentially have the same flow, and we know that floodplains don't behave that way. There is attenuation, there are changes in flow as you move down the reach, especially in a wide floodplain that stores a lot of water. Now, you don't get to see those impacts with a steady state one-dimensional model. You're also looking at cross-sectional geometry and flow in a single direction. We know that water doesn't behave that way. And you're essentially blind between these cross sections. And a lot of these older studies had cross sections that were, thousands of feet apart. So you didn't really know what was happening between those cross sections. So we have much better tools to assess, the dynamics that we see out there in the Carson. And that's where 2D modeling comes in, and that's where we're kind of pushing boundaries with this study, and we're kind of forcing FEMA to take a closer look at using these new tools which we have available now and the new technology to really do a better job of managing our floodplains. So the advantages of 2D modeling is that you can look at this dispersive flow patterns. You're not guessing at how the cross sections should be set up. It's much more informative than the static mapping. You're flow goes in many directions, and you're able to model that and model flow in multiple directions. The tool that we are using for this study is HEC RAS. 6.0 is the current version, and it's a hydrodynamic model that uses 1D and 2D. It uses these grid cells to pass water across the floodplain in many directions. It's a meshed component, so you don't have cross sections like you used to. It's a mesh. It's a computational mesh, and I'll show a picture of that in the next slide. And you can get very detailed hydraulic properties across this mesh. And as we look at some of these images and simulations, you'll see why this is a much better way to look at our floodplain. So this is kind of what the mesh looks like. You'll see that water can move from cell to cell to cell in many different directions, instead of that image I showed you before, which was just very static cross sections spaced pretty far apart. So if you're looking at dynamics in the Carson Valley, and you're looking at something like this, it's really you can't model something like this in one dimension, and you're not really doing the dynamics any justice. You really do need a two-dimensional. As you can see, the flow patterns are much more complicated. So Carson River hydraulic modeling specifically, we are using this 1D, 2D modeling, and we are using unsteady state. We have one model for the whole watershed now, and we can look at these impacts. There's consistency. We're not looking at piecing a bunch of different models together to look at our floodplain. It's an efficient way to look at this, and once the model is set up for the whole watershed, it can be used and save some cost to people that are looking at projects in the future. And one example of that is that Douglas County is currently tracking impacts to the floodplain as permits come in. The construction applications come in. They're looking at those cumulative impacts, and they're using this model to do it. This is kind of what the model looks like. And you can see it's pretty complex. There's the east and west forks, they merge. This is kind of the area and they go down to the Carson City boundary. But you can see all of our overbanks are two-dimensional. The channels are all one-dimensional. But we're still looking at a very dynamic system with this two-dimensional overbank modeling. This is kind of an example of how that mesh looks and how we set those things up for the water to flow in the overbanks. So this is just a visualization. You can see how complicated these floodplains are and how the water moves through there and how we're capturing those dynamics that were really impossible to look at with a one-dimensional world. And so you can see there is time component here. And this is just the grids, how the grids are laid out and how the water moves through the grid cells and how it's just very, very dynamic. Another one of the entire watershed. You can look at all these inputs to the watershed and you can see how complex. You could not model this with a 1D model. So I'm coming to a close here, and I just want to talk about how we are kind of pushing boundaries here with FEMA and the CWSD. We're kind of pioneering these two-dimensional flood hazard mapping and the submittal process to FEMA. The few studies that we've done to date, we're also working on a project on Pine Nut Creek, are going to be some of the first two-dimensional submittals in the country. So, we're forcing FEMA to kind of review their guidance, and they're changing their process and their um, documentation and their regulations for a change as the tools change. This has been a long time coming, but they are recognizing that these tools are becoming much and much more commonly used, and that process has to change. And you can see on the right, in November of 2020, FEMA actually is starting to give guidance on two-dimensional analyses. So this is exciting. We have our first submittal going in, soon, and so we really will, be exciting to have this new mapping and new modeling in the Carson Valley, and have FEMA, look at this and get feedback and, use this new tool to really look at have a really good picture on how our floodplains behave and how any kind of construction or projects will impact that floodplain. And that's all I have for today. Thanks for listening. And if there's any questions, let me know.